What I'm going to show you now is how two lines in space can define a plane. And if you think about this piece of paper here as a plane, and I can draw one line on it and another line. And one of the facts of geometry is that any two lines in space are coplanar. They define a plane. So if we look at the stereo net that I've annotated with the position of two lines, I've got line 1 here and line 2 there, represented by these points on the stereo net. Those lines lie on a plane, and we can use the stereo net to find that plane. It's very simple. All you do is rotate the stereo net until you find a great circle, one of these things, a great circle that captures both lines. And I've got one here, and I'm just going to draw it out. I always like to mark a little tick at the edge of the stereo net. Try and be reasonably accurate. Out to the end. Now I've captured the strike of the plane that contains the two lines L1 and L2, and I can actually draw its pole here at the same time. This is the dip line, 90 degrees away from the strike, and that is 4, 14, 24, 34, 44, 54, 64, 74, 84, 86, 88, 90 degrees away is the pole to that plane. Now if you want to know the orientation of the plane, the strike, you look at where the plane intercepts the edge. This is east, which is 090, that must be 080, and we're 4 degrees away, that's 076. And the dip, count in along the XY line, 10, 20, 30, 40, 50, 60, 66 degrees. That is the dip. So the plane has a strike of 076 and a dip of 66 degrees. And if you look at the way you've constructed your stereograph, that dip is to the south. So now we've defined the orientation of a plane that contains the two lines L1 and L2.